All right, guys, this is the 5.1 video notes. So we're switching over from experimental design. Now we're going to talk about probability. So this whole chapter is going to be a little more math heavy, but yeah, we're going to talk about probability this whole entire unit. So I'm going to start with a bunch of definitions here. So the first one, what is the law of large numbers? This is the idea that if we observe more and more trials or repetitions of any chance process, the proportion of times that a specific outcome occurs approaches a single value. Right. So best way to think about this: if you're flipping a coin, and while it may not be 50-50 at the beginning, in the long run, it will eventually get to 50-50. So how do you interpret probability? Probability is the probability of any outcome of a chance process is a number between 0 and 1 and describes the proportion of times the outcome would occur in a very long series of repetitions. So here, the next question, the probability of getting a sum of 7 when you're rolling 2 dice is 1/6. So interpret this value. So you would say something like, after rolling 2 dice many times, about 1/6 of the sums of the 2 dice will equal 7. So those are kind of just some basic definitions of what probability is. Okay, so what are some myths about randomness and probability? So the biggest one that students will make a mistake on is when they see a pattern in the short term. Okay, so probability is all about long-term proportions. So probability looks at long runs. However, when we see a strange pattern in the short term, we tend to look for other explanations other than chance variation. So for example, if we flip a coin and the first 15 are all heads, we as humans tend to think that something else is going on, but that can happen. While it's unlikely, there's still a chance that it can happen. So then how do we replicate these chance processes? So how do we actually conduct these? So on the first page, I said we could go ahead. We didn't do this, but you can imagine flipping a coin 50 times, right? And you see how long that would take. So then what we can do is we can use computers. It's a great thing about technology to reproduce the same outcomes, right? So we do these things called simulations, which imitate a chance process or behavior. We use computers and calculators. All right, next one. What are the 4 steps? So these 4 steps are going to be kind of like what we're going to do now for the rest of this semester. So there's, whenever you see some of these problems are going to get pretty long. And so basically we just break them down into these 4 steps. And these are kind of the 4 steps you're going to use every time. So the step 1 is called state. And this is where you ask a question. In our case, in this chapter, we ask a question about some chance process. Chapter 5. Right. So in chapter, once you start doing significance testing, chapter 8, 9, 10, 11, we say, are the results significant? That's going to be our question. But right now we say, what's the likelihood of this chance process happening? Okay. And that leads into step 2, which is your plan. This is where you describe how to use a chance device, right? Either a calculator, a computer, or a table to imitate 1 repetition of the process. Okay. You need to tell the reader what you will record at the end of each repetition. Okay. Talk about repeats. Well, we can go to the next step. So step 3 is when you do it. So then you actually go out and you perform many repetitions of the simulation. And then step 4 is where you conclude. This is where you use the results to answer the question. So we're going to be following these 4 steps kind of throughout the rest of the semester. All right, so now if you read this little story about this woman who thought she could smell Parkinson's. And so the first question, assuming guessing is at random, what is the probability she will guess correctly? This is 50-50, right? So 50%. She either guesses correctly or she does not. Right, so if she's smelling, I think she smells 12 shirts. If it was random, she would only guess 6 correctly on average. That's kind of the idea. Okay, so now in the original experiment, this woman, Joy, she identified 11 shirts. Okay, so does this provide convincing evidence that Joy can smell Parkinson's? Design and conduct a simulation to do this. So here, right, the first thing you do is consider how we will do the simulation. I said here that you can flip a coin where we let heads equal, guessing right, and tails equals incorrect. Okay, you can flip that around, doesn't matter. And then we will conduct 12 trials per round. And look at the number of rounds where we get 11 heads. Okay, so we'll do that multiple times, and we'll take a look at the proportion of times that we got 11 out of 12 heads. Okay, you can also use rand_int on your calculator. That's another way of doing it. But this here is kind of how you would set up this set the simulation. I'm going to do one on the next page that's a lot more in detail. So what are some common errors when using a table of random digits? Students do not communicate the methods they are using. This labels, we kind of talked about this, need to be the same length. I.e. need to be 0001 to like to 1500, for example. Not 1 to 1500. You talk about replacements and repeats. So we kind of talked about all those things before. Okay, so now last question in this video. So we're looking at selecting seniors and juniors. And so at first we thought about just putting all the names into a giant bag and then kind of randomly selecting. And so now we're going to decide. So yeah, but then obviously someone says that, oh, well, seniors and juniors can be different. We kind of should stratify based on those. And so, but since we've already put the names in a bag, we don't really want to separate them all out. That's just a lot of time. So instead, I'm going to select names one at a time until I get 4 seniors and 2 juniors. That's kind of the idea. So this means that I may need to select more than 6 names, i.e. I may get more than 2 juniors before I get 4 seniors. Design and carry out in a simulation using table D. And yeah, we'll go from there. So first thing is state. So I'm going to follow those 4 steps, which is what are we trying to do? So what we're trying to find, this is the question, what is the probability that it takes 8 or more selections to get 4 seniors and 2 juniors? Another question. So now my plan, okay, so now I'm actually going to set this up. So using, and it says here to use table D, so that's the table of random numbers. We label seniors 01 through 60 and juniors 61 through 90. Numbers 00 and 91 through 99 will be skipped. We will look at pairs of digits until we get 4 different pairs from 01 to 60 and 2 different pairs from 61 through 90. So if you read this as a reader, someone else was reading this little simulation, they will kind of know exactly what I'm doing. And they could, we talked about being replicable, right? Someone else could repeat this pretty easily. Okay, so now if I'm starting at line 101, you're going to use a number, student 19, who's a senior. 22 is a senior, so I was labeling him S. 39 is a senior. 50 is a senior. 34 is a senior. 05 senior. 75 is your first junior. And 62 is another junior. Okay. So here we say that it took 8 selections to get 4 seniors and at least 2 juniors. And now I'm not actually going to make you do this, but in ideally you would repeat this process many times to find a probability. So you do, let's say, do like 50 trials, 50 rounds or trials of this. Right. And then you could then conclude with your proportion. Okay. So that's kind of how we use those 4 steps to kind of run this whole process. So that's the intro onto probabilities and simulations, guys. Again, as always, if you have any questions, please let me know. But if not, have a great rest of your day.